Sorting algorithms. I know. Everybody keeps telling you that you have to learn them. No idea why they are important, and they seem like such a huge hassle to you. Or maybe you just started learning data structures and algorithms, and this is usually your first stop. Usually, when you start learning any sort of algorithm, bubble sort is the first algorithm for you to learn. Today, we will talk about bubble sort slowly. We will talk about how it works step by step, and we will implement it both in JavaScript and in Go. Let's go. Let's say you have an array that has 8 numbers inside of it. You want to sort this array from smallest to largest, but you have no idea how to do that or how to even approach the problem. So what do? You cut down the big problem into smaller problems that you can solve. Sure, you have no idea how to sort an array with 8 numbers in it, but you surely know how to compare 2 numbers. So you simply do that. So let's start with the first element. What we are going to do is what we know how to do. We will simply compare every 2 neighboring numbers in the array and swap them if necessary. So let's zoom into the first 2 elements and have a closer look. Let's ask if 1 is smaller than 7. Yes, of course it is. Cool. There seems to be nothing to be done here. So let's put those back and move forward 1 index in the array. Let's pick the second element and its neighbor and have a closer look. Is 7 smaller than 6? No. Okay, cool. What can we do? We can swap them. Let's do that. Nice. Looks much better. Let's continue. Let's do the same thing, move forward 1 time in the array and compare it with its neighbor. Oh, hello again, it's the same 7. Anyway, let's zoom in on the 7 and its new neighbor, now the 4. Is 7 smaller than the 4? No. Of course, we do a swap. Nice. Cool. Now, let's move on 1 more index forward in the array. Hello again, it's the same 7. This is fun. Cool. Let's compare the 7 and its newest neighbor, the 8. Is 7 smaller than 8? Yes. Nothing to do here. Sounds good. Now, before we proceed forward, let's just take a step back before we continue. I noticed that the element 7 seems like it was stuck with us for a while there. So what actually happened? The element has effectively moved from being the second element in the array to being the 4th element in the array. Do you guys know what just happened to the 7? It bubbled up. And that's where the name of the algorithm comes from. The biggest numbers simply bubble up to the top. Moving on. 1 more step forward and we find ourselves with the 8 and the 9. Yep, you guessed it. Nothing to do here. They are in the right order. Let's put them back. Let's move on 1 more index to the front. We find 9 and 3. Are they out of order? Yes, they are. You know it, let's just swap them. 1 more step and it's the 9 and a 2. Let's swap those in place, super easy peasy. You get it, right? It looks like the 9 also bubbled up. So it started at there and ended up being the last in the array. That is also bubble up. That looks really cool. So and that's what we do here. We are simply bubbling things up to the top. And that's kind of like a side effect of simply comparing each element with the next element and swapping them if necessary. And that's why it's called bubble sort. Cool. Now we have reached the end of the array. So what do we do now? Well, we know that we have been swapping a lot already. That probably means there's still more to be swapped. It's an indication, right? So we can give it another go. So let's go again over the array from the beginning. 1 and 6, that's sorted already. Cool. 6 and 4, quick swap. Beautiful. 6 and 7, sorted. Awesome. 7 and 8, sorted. No gift this time. 8 and 3, quick swap on this one. Quickly, we sort it out. 8 and 2, say it, quick swap, let's go. Finally 8 and 9, that is sorted. Cool, we have reached the end again. Guess what? We have been swapping like there's no tomorrow really. Most probably, there is still more swapping to go. Okay, I'm gonna let you do this round yourself. 1 and 4, 4 and 6, 6 and 7, 7 and 3. Look at you go. Fantastic. 7 and 2. Yep, you know it. 7 and 8. 8 and 9. Oh, good. All right. Now I'm starting to yawn, really. So let me fast forward, and you know what's happening at this point. All right, that is done. That looks really good. Give yourself a clap. That was a long array, and we have sorted it out step by step. Awesome. Now, let's try to reflect about what we did there and try to come up with a plan that we can implement in our algorithm. So what we did was actually quite simple. We went through the array one element at a time. We compare that element to the next element. If the element is bigger, we swap it, kind of like let that element bubble up to the top. Otherwise, we just move forward. When we reach the end of the array, we ask ourselves a simple question. Did we swap anything? If so, probably there is more to swap. Did we do it again? If we didn't, then that's all good. The array is sorted. Great. Now, let's head on to see how we can translate that into some fine JavaScript code. Right now, we have a function called bubble sort. That function doesn't do anything. It takes an argument called nums and returns that argument without manipulating it. Let's change that. Let's try to implement the pseudocode that we have written before. The first step is one element at a time. For this, I will add a for loop. That's super straightforward. Secondly, I need to compare each element to the next element or the neighboring element. Let's add an if statement for that. If the statement is true, we will swap both elements together. Let's do that using a temp variable called current. Okay, cool. What should I do when I reach the end of the array? I need to ask myself if I've swapped any elements or not. For that, let's add a variable to track it. That variable is named swapped, and it will start its value as false. Let's also set it to true right after we do any swapping. Looking good. But now what do we do? What should we do? We should do this loop as long as we are swapping, basically. So as long as we keep swapping things inside the array, that means we should go another loop on the array, because that means basically we haven't finished sorting, and so we need to go one more time. That sounds like a do while loop to me. So let's do that. Basically, do this for loop as long as swapped is true. Nice. Now let's reset swapped in the beginning of each loop, do loop, so we don't get any bugs. And that's it. A super simple implementation of bubble sort in JavaScript. Now that we are done with the JavaScript example, let's have a look on how we can do this in Go. Go and JavaScript are quite different languages. But however, you will see now that the implementation will look quite similar. First of all, I have here a function called bubble sort. This function takes a variable called nums, which is a slice of integer, and basically just returns a slice of integers, so this function does nothing. It simply returns the array. Now, the first step, exactly like we did with JavaScript, is to add a for loop. In this case, we are looping over the array items, and when it comes to Go, we have to make sure that we don't go over bound of how long the array is. Hence, this -1 that we have here. Cool. Inside that, we need an if statement, again, very similar to JavaScript. We are comparing nums if, nums I, to nums I plus 1. And then consequently, if the statement is true, we will do exactly the same thing like we did in JavaScript. We are simply going to swap them using current as a temporary variable. Good. So far, so good. Now, at this point in time, we need to keep track of if we have swapped an item or not. For this, I'm going to start by adding a variable called swapped, and in this case, we are going to initialize swapped to true, not false like JavaScript. You'll see why in a moment. Now I'm going to assume again that at this point, something else will set it to false. I want to make sure that after I swap, I've set that to true. Now, the reason why we initiated swapped as true is because in Go, there is no do while. So I'm going to simulate a do while loop using a for statement. So for swapped, do blah, 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 right? So, which is the same. As long as swapped is true, do blah, 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 blah. The only difference is in JavaScript, we do the thing first, and then we check the condition. In this case, it's a for loop. So as long as swapped is true, the for loop will continue to run. And hence, that's why we started swapped as true. But obviously, this doesn't look right. We need to reset swap to false after we step into the for loop. So as long as swapped is true here, which is basically being set to true here, that means this loop can keep going. And that's it. A super simple implementation of bubble sort in Go. That's it. That's bubble sort. Really simple and straightforward sorting algorithms. Usually your first step when you're learning algorithms for a reason. I hope today that you've learned the ins and outs on bubble sort, conceptualize it in your mind, and I hope you liked this video. If you did, don't forget that thumbs up and subscribe as well. I'll see you guys in the next one. Ciao.